Okay, so the diagram shows a horizontal cylinder oil tank of length 2.2 meters, 2.2 meters, and radius, well, that's 90 centimeters, so this is the same. So let's just understand, if we want to connect this back to what we were just doing, then we have a 90 centimeter cross section here. So let's immediately recast the problem in centimeters rather than in meters. So find in liters. Now, 1,000 various ways of looking at this, but a milliliter is equal to a centimeter cubed. Is one way of looking at it, and we know a liter is 1,000 centimeters cubed. So if we want things in liters, and we want to convert from centimeters cubed, we divide by 1,000. Another way of judging a liter in terms of a cuboid, or in terms of a cube, is that it's 10 centimeters cubed. Okay, so obviously your liter of milk will come less than 10 centimeters this way and more than 10 centimeters this way, and so on. Okay. So the diagram shows a horizontal. Okay, we've read that. So find the total capacity of the oil tanker. Okay, so you should not need to do this. You should know the cylinder is based by height, but we can use, so there's the formula there, pi r squared h. No harm in writing it down, just in case you make a mistake later. So pi r squared h, which is equal to pi by 90 squared by 220. And if we want it in liters, we can divide by 1,000. So let's do that up front. Okay, so start your fraction bar. You'll end up spending more time figuring out when you can leave out multiplication signs. You do not need a bracket on the 90 to square it, that's for sure, because 90 is just a number. And multiplied by 220, down you go to 1,000 to divide out the 1,000. Now we get 1782 pi. 1782 pi. That's in liters. And I can digitally expand that to 5598. However, I've just got to watch something. It does say to two significant figures. Okay, so when I say 5598 liters, these are not significant. So I can treat that as 5,600 liters. Excuse me. Now, dipping is a method by which the level of the oil remaining in the tank can be checked. A graduated cylinder is used to measure the level of oil from the bottom upwards. It was found that the depth of the oil tank was 60 centimeters. So the depth was 60. So basically we're dealing with the exact same circle as we had over here. And the depth was 60, and it's important to remember to connect them, because it's the exact same. Remember, we had 90 in total. Now I remember thinking to myself, I won't bother calculating that at the time, but now it becomes very relevant, because now all we have to do is take this area and it's in centimeters squared, and we're dealing with it. We keep dealing with dividing by 1,000 to go to the we'll keep dealing with dividing by 1,000 to do. So I think you know what I mean. I'll move on with it. So basically, what we're doing is we're just taking 7425 and multiplying it . That was the full thing. So we're taking that and multiplying it by 220 and dividing by 100, which is very easily done, and dividing by 1,000. In fact, I can just come in here and edit this and get rid of top left corner. Okay, because the 220 and the 1000 was common, and I pop in 7425 there. Okay, and I'm going to store it to be get 1633.5 liters. Okay, and remember that's stored to be, and now they keep asking us, you know, we're doing some rounding, and my general advice is, despite the fact that the scientist and indeed the mathematician in you might say, why am I introducing error when I don't need to, when I know the data more accurately, but they're expecting you to go with the rounded values for future calculations. That might not seem like a great plan, because you have a thing called building errors. They propagate through the system, and sometimes they can kind of get a bit inflated when there's differences involved. But that's just not what we do in Leaving Cert Math. So you just use the rounded values as was instructed previously, and that's what the marking scheme is going to end up doing. You probably would be absolutely fine not to, but it becomes quite tedious if you're not relying on memory bank to start filling in all the digits. Okay, so to make a long story short, the two numbers that I'm going to be focusing on now are that and B. So basically, looking at the cross section, B is using up that, and I might just, I can't remember what A was used for, but I will just put in 5600 liters and store that to A. Okay, so basically we can say this is A now and this is B. Okay, so we push on. After a fill of oil tank is delivered, the tank was dipped again and it was found to be at 160 depth. So that would leave a 20 here. Okay, so I'm interested in getting this, what's called the major segment. Volume, because it goes off that way with 220 running this way. Okay, now to do that I'm going to need to know this angle. So what's interesting is the last question was an inverse sine. This is going to be an inverse cos. Why is that? Because we're looking at 60 if we want to use the symmetry of the situation, with 60 going this way. And you can see that the connection between trigonometry and cylinders and circles is the fact that you have these isosceles triangles all the time, and that brings its own symmetry with it. So you have 60 that way, and you have 90 this way. Okay, but remember we want double the angle, so we'll push that up front and say that the angle alpha is equal to double the inverse cos. Oh, hold on, is that cos or sine? That's sine. And was the other one cos? Doesn't matter what the other one was. This is clearly sine. So the inverse sine of 2/3. Okay, because 6 over 9, 60 over 90 is 2/3, 6.666. So I'm just trying to show you how to put in your calculator quickly. 2 because you're not actually interested in the half the angle, you're interested in the full angle, which is 2 alpha. So it's double, and then just go 0.666 loads of times. Okay, that will make sure there's no error of any relevance at the precision we're working with in. So that tells me that the angle being opened is 83.6 degrees, 2 degrees. And now I just want to very quickly, be very careful, sorry. It's actually all of this, it's the complement of that in terms of a revolution. So we're going to subtract 360. It's a little bit of a problem, but this is my way of doing it. And I'll just ignore that minus and call that 276 degrees, because it's a reflex angle we're dealing with when you're going over to being a major segment. Okay. And it is important that you recognize that it's just a segment, and that you're able to work with major segments, and that you don't have to come up with some compounded equation. You just use the equation like normal and a reflex angle. Okay, so the reflex angle is 276 degrees, and putting in extra precision here is just not worth it. It's not going to make any difference at the end, so let's go with this now. And I will just convert that quickly to radians. Let's say theta in radians, and I'll multiply by pi, and I'll divide by 180. And I don't have to do that in a fancy kind of display manner, and I get that in radians it's 4.824. So now we're heading into the formula, which says, you see, the formula for a sector is half r squared theta minus sine of theta, provided you use radians. But what you can do is bait and switch here, and switch back into degrees by the time you get to there. So in other words, you can go half. Now the formula isn't in the tables, but you've worked this out often enough, okay? And in a previous part of this question, I didn't use half r squared theta, I used this one. But you should be flexible to switch over and back between them. So 90 centimeters. Remember, I'm going to bring in the 220, and I'm going to expand this out into the volume, okay, which will bring 220 centimeters over 1,000 into it as well. Okay, so I've got half 90 squared, 4.824 minus the sine. Now I could change my calculator into radians, but to be honest, I don't want to do that very rarely, because it can cause great problems if I forget to bring it back. And by writing this as minus sine of 276 degrees, I can avoid that. I can multiply by 220 and divide by 1,000, or I can multiply by 0.22, and I want it to go down to the 1,000. Okay, so let's get that 0.22 done up front. 0.22, and divided by 2 would be 0.11. Be very careful with these things, but now I've dealt with that. It's 90 centimeters squared. That point means multiplication. Multiplied by 90 squared. Open up a bracket. In radians, it's 0.4824 minus the sine of 276. There's a double bracket there, and that's the area, the volume of this total. So if we look at our volumes and keep them being compared with each other, the volume here, I'll call it C, and it's 5184. So you can tell that the A bit doesn't really matter, because we were at this level. So what I want to do is subtract B, but I'm not going to risk. So I have that on my calculator now, and I'm going to subtract B minus, and just recall B is the quick way of doing it, and we get an answer of 3551 liters should have been delivered. Which looks just about right. I'm going to double check one thing, and that is that B is as I expected it to be. So I'm just going to recall B and make sure that that was the 1635. Yes, it was. Okay, so I get 3. So the delivery entailed 3551 liters. Now, you know, you could be out by looking at the marking scheme, and it's just ever so slightly different. 340 about. Yeah, I don't need the empty portion. I just want the model, didn't I? I did that entire segment there. Subtract that entire segment. Yeah, so that's the answer there. The marking scheme is a small number of litres slightly different. However, the marking scheme quotes 3627 litres being delivered, but I'm pretty certain there's very little error there between them, is there? Difference between 35.5 and 36 and a bit. It's probably just due to choosing different levels of accuracy and precision down the way. So you're looking at almost full credit, if not full credit, for that question there as answered. Okay, thank you.